Hi, my name is Ajmal. Today I'm going to give a presentation on how going from the OpenShift POC to production and what are the benefits of for the client in terms of revenue, in terms of value proposition, and how the objectives of going from monolith application to the production could benefit the enterprise. The key takeaway would be bringing containers to production from different adoption paths, impact on ITIL framework, the people, process, and governance, and DR, disaster recovery. Technology consideration, which includes the security, the overall enterprise architecture, that includes the data management and the security protection. And how technology could help you adopt and plan ahead for success. Let's see, the goal of the presentation is to talk about some of the issues that the customer will experience as they shift from OpenShift POC to production. Then we'll talk about how you can use and technology to accelerate that journey. 4 options that are a pathway to adopt containerized applications. This slides talk about 4 potential approaches customer can take on their adoption journey. Complexity will vary depending on the approach. First, deploy the containerized application. That would be in days, verified and secure. Containerized monolith application, migration to hybrid cloud, bare metal, or get a better CapEx and OpEx versus the current structure. How the containerized monolith transforms to microservices, and the transformation of the agility, DevOps, distribution architecture, and adoption of how the business could scale. Enable new microservices and application. The key considerations are complete POC, often a minimum viable product, and how you're going to manage those people and organization, DevOps and release process, the governance, technology, and platform. But now we run into tooling and the process problem. Most organizations that are 5 years old have ingrained habits of using outdated tools. Training and processes specifically designed to manage virtual machines. Trying to force fit VM-centric management tools and processes to container can result in a very large frustrating back of difficulties. Network consideration like opening out and inbound ports, security clearance, security audits might be many weeks. Ops guys might ask for the books, run books, and how detailed operation will work. Abstract, complex, JBoss, Postgres, and how these components could work together to provide a fine solution. How do you change the management without any system takedown? Do we take POC learning and apps into the production, or goal is to turn into repeatable and optimized process in future projects? Governance includes a global assessment of the organization and the planning of the service rollouts. Service operating model, service levels, agreements, support, licensing, chargebacks, training, and enablement of the different teams, internal marketing of the services. Application and dev processes for each application, assessment of its technology stack and architecture. Application operating models and deployment patterns. Development team and training and best practices. Containerize and operationalize the stack components, automate building, testing, and acceptance of the applications. From the platform perspective, requirements and the planning, global architecture, platform operating models, integrating with existing infrastructure and IT system. Operationalize for high availability, disaster recovery, testing and acceptance of the platform. People, organization, and governance. The two teams are collaborating through OpenShift lifecycle that provides a separation of concern as the contract while greatly improving the two teams' collaboration in the application lifecycle. The developers own the container contents, its operating environment, and the container interdependencies, whereas the operation team take the built images along with the manifest and run them in their orchestration system. Ops model, who is doing the support training, also good time to consider CapEx versus OpEx model during this transition, which will have people and organizational impact. So what used to take 1 to 3 releases per year will take considerable of 4 to 12 releases per year within the 3-month cycle. From the 4 to 12 months, you can understand how these savings can be done from that perspective. If you have remember about governance about who owns what and who is responsible for what. Updates, enhancement to make in your DevOps processes. Governance, different organizations touch registry contents, figure out which apps to take to production. Key things is figure out ops model early. What is the SLA? Who owns what? Who is doing the support? Who is making the changes on the platform? What is the promotion policy from the dev to production? For example, with no ops model for images, say there is a vulnerability on a base image. What is the update policy to these base image? Expect to create, architect, and maintain at least as much test code and automation scripts as you create production code. One of the most important culture changes from aligning work across the organization is having all the teams continually integrating and testing their code in a production like an environment. Technology consideration. What type of storage to use, the configuration management, the SSO, and how to handle the secrets. What you're going to get is the high availability, data protection, orchestration, and of course from the operation side, it would be monitoring, scaling, and the resource management. Kubernetes security like monitoring or CI/CD is becoming a must as a consequence of these platforms quickly gaining the reputation as a de facto standards for modern containerized deployment. OpenSCAP verifies the presence of patches by using content produced by the Red Hat Security Response Team. Checks system security configuration settings and examines systems for signs of compromise by using rules based on standard specification. To effectively use OpenSCAP, there are 2 requirements. A tool to verify a system conforms to a standard RHN satellite server has integrated OpenSCAP as an auditing feature for version 5.5. It allows you to schedule and view compliance scans for the system through the web interface. Unfortunately, the traditional security processes needs to be updated for Kubernetes. Legacy security tools that were not built from containers cannot look inside, analyze or protect containers, microservices, and cloud-native apps. Containers are black boxes, useful for moving application from development into production, staging, and to production. They provide a great level of portability and isolation, but it's harder to understand what's happening inside to monitor and secure them. Microservices help to develop application faster, and orchestration tool like Kubernetes allow to deploy and dynamically scale the apps. But now we have different pieces moving around. Therefore, we must take more dynamic security approach. Further, many organizations are adopting security best practices and implementing DevSecOps processes. where everyone is responsible for security, and security is implemented from early development stages into the production to the entire software supply chain. This is also known as continuous security. OpenShift provides security context constraint SCC that controls the action that a pod can perform and what it can access. In short, when we execute a container, we want to guarantee that the capabilities required by the container to run are satisfied, while at the same time, we also want OpenShift to be secure container application platform. For this reason, we cannot allow any container to get access to unnecessary capabilities or to run in an unsecure way. Example may be privileged or as a root admins. A best practice for application security is to integrate automatic security testing directly into the build or CI/CD tooling. And scanners for real-time checking against known vulnerabilities like security, black duck, JFrog, many more. Tools like these catalog open source packages in your container, notify you any known vulnerabilities, and update when new vulnerabilities are discovered in previously scanned packages. CI/CD process should include policies that are automatically open issues when security vulnerabilities are discovered in the build process, so the DevOps team can take immediate action and to resolve the problems. Finally, there is an effort underway by Red Hat, Google, and others standardized auditing policy enforcement with Kubernetes. Let's talk about the value add in this area. The Encon storage security, the SysDic alliances, and many other more. So when we are talking about the securing the stack, it's all about containerized images, registry, Red Hat Linux, and the overall hardware firm and BIOS upgrade. From the monitoring consideration, app matrices perform stats, request counts, request times, request errors. Services are they working correctly? Middleware, database, backend. Kubernetes is doing its job enough. Enough pods and container are running for each apps. Are pods available? Liveness and the readiness probes. Are deployments stuck or on a rolling update? Scheduled, running, available, desired maximum unavailability. Is Kubernetes internally healthy? Internal services like Kubelet, API server, and Docker, etc., etcd, etc., are nodes ready for unschedulable, available resources, events. How are my physical resources doing? Are the nodes up and resource available? CPU memory, disk network, recommended commercial monitor for more complex environment. Typically where the DevOps or the platform ops is responsible for software in production, where there's a mix of custom metrics types. There's a desire for troubleshooting as well as monitoring data. There are requirements around long-term data retention, management, and user access. I'm going to skip out of the code part. Here you can see the deployment, the configuration, and the enterprise level production, and how OpenShift can assist you doing just that. Bringing development to the staging and finally to the production. Accelerate the development and productivity. Simplify the IT experience. That is operations optimization. Deploy the solutions for enterprise scale container deployment. Deploy containers at a cloud-like speed. improve the application time value, centralize container lifecycle management, reduce updates from hours to minutes, flex container resources up and down, efficient resource allocation by business demands, advanced container data management, data production, storage efficiency for containers, data management and production. There are four components: lift and shift, DevOps, CI/CD pipelines, IT operation, where the simplified security, easy to manage, and many other tools as per the needed enterprise requirements. And of course, containerized as an application. Self-service for developers, secure and predictable environment. Hardware versus software. Replication, spray and paint. This is how and what capabilities OpenShift could help you get. If you notice, there are reliability, availability, and serviceability, backup and recovery, cloud native, checking of the performance, storage reduction, scale and grow, efficiencies, and consistent models. Self-service automation, rich container platform integration, speeds up the container platform integration, comprehensive REST API plugin to Ansible, Puppet, or Chef. So you can see that there is a speed up for DevOps section, and that are all self-service automation once the adoption has taken place. You can capitalize on various platforms, cloud platforms, from the harbor cloud computing perspective, and and you can simplify the container operation, which is simple, fast, efficient, and scalable. And not to forget to mention that container data protection, the cleanup, the retention, all are taken care of it. There's also the term OpenShift assists us in persistent storage, so that the data is not lost when the pods die out. This is a simple architecture which can be followed. This is when the production OpenShift is in production. So you basically get the improved highly available lifecycle, which can be highly available. Performance control is there. Volume placement is there. Protection, security, provisioning, zero copy clones, reuse the data from the production containers, and of course the volume import. Service for OpenShift. Container and cloud adoption is not travel. You have a discovery, you design the solution, and then do the deployment. Of course, there are a part where you have to do the pilot testing. In short, the DevOps, build and test, package and archive, and release and deploy. This brings the container, the advantages of the container upfront from the CI/CD or the continuous integration and deployment pipeline stuff. Announcing cloud native container service for OpenShift. The service typically flows in 3 steps. The first being the discovery, like I mentioned earlier, in order to help your developers, test team, and operation achieve peak productivity. We need to take the application, technical businesses, operational requirements into careful consideration. Discovery, answers questions such as what system is integrated and how your team will deploy containerized applications, and how do we secure scale to meet business needs. The design phase makes sure that the requirements are realized in the subsequent deployment. Once your environment is deployed and configured, we execute pre-production tests and help you work through onboarding cloud-native containers into your deployment. Finally, plan for success. Move from POC to production. The key success parameters would be implementing the best practices and address issues, learning from the POC, people, processes, and technology, the ITIL framework, or the EA, Enterprise Architecture framework. Have a complete OpenShift container ecosystem in place, HA, security monitoring, compliances, monitoring, data management, etc. Determine the CapEx versus OpEx. Plan whether to do it yourself or partner with us. Thank you for having me on board and listening to my presentation. I hope you enjoyed the video. I will be more than happy to have your questions and to answer. Thank you.